Whenever we study organic chemistry, we hear a lot about functional groups. So what I have brought today for you is common functional groups. So let us quickly revise. Hi, I'm Neha, and in the playlist of organic chemistry, you're watching this video wherein I'm going to cover all of the common functional groups listed here. So just have a quick look at it. Let us quickly revise. First type of compound is acid chloride. Now the name suggests here is an acid, here is a chloride. Chloride, I guess you remember, comes from chlorine. So here you have a chlorine, and normally acid is carboxylic acid, which is C double bond OH group. Here if you can see it's carboxylic acid, R C double bond OH group. Now if you replace this OH with this Cl, it becomes acid chloride. So the functional group is first one, acid chloride, RCOCl, where R could be anything. So here CH3 has been substituted for R. Functional group you can directly say as COCl. Second functional group is very easy, alcoholic group. We all know it is OH group, hydroxyl group, ROH, and R could be anything. Starting from CH3, then you have C2H5, you can have number of carbons increasing here. Coming to the third one is aldehyde, which is CHO group. It do have carbonyl group, but then here it is confirmatory that you have an H here, right? If you have a carboxyl group, carbonyl group, which is C double bond O, now this carbon can be connected to either R or H. It could be R if it is ketone. Fine, but if this R is fixed that it has to be H, then it becomes aldehyde. So what is the difference between aldehyde and ketone is very clear, that it is RCHO and ketone is RRCO. So there you have two R. So this has to start with first carbon, while here it has to start with H. So there has to be a H here. So this becomes aldehyde where you have RCHO. This becomes a ketone when both of the R are starting from C. It could go in the range, like carbon number can increase, but then there will be no H on the side of carbonyl group. Coming to the next one is alkane. That means only carbon and hydrogen. That is alkane. Coming to alkene. Alkene means ene. Ene means double bond. That means the carbon should have a double bond. And when it is having a double bond, you can have anything here, either R or you can have a H. It's R always starts with H, or then you can start the number of carbons, like you can make it CH2 or you can make it RCH2, increase the number of carbon. Let us go down to alkyl halide. Alkyl halide, alkyl obviously R, and then halide could be anything. Fluorine, chlorine, bromine, iodine. So if it is this, it would be methyl bromide because I have used bromine. Similarly, you can have chlorine and you can have iodine or fluorine. So alkyl halide is RX. This is a halo group there, halogen group is there. Coming to alkyne. Ine means triple bond. So here if you have triple bond, that means alkyne. Now this one, 2 carbon is there, so ethyne, and then you can increase the number of carbons. So basically a triple bond has to be there. Alkane, there is no bond, I mean single bond. Alkene, there is a double bond. Alkyne, there is a triple bond. Coming to amide, amide is CONH2 group. So this CONH2 group is amide. Now here H, you can again change it with R. So one H is there, one R is there, or both of the things are H, or both of the things are R. These are the combinations, and that's what they are written here. So basically you have a CO group which is joined to a nitrogen, and then nitrogen is joined with either H or R. So this group is amide, and that's how you can write R here. So CH3 RCONH2 or any R. So CH3CONH2 is the amide as of now. Clear? Nomenclature or naming we can do in another video. Today's video is mainly focused on to tell you which functional groups could be available in your compound. Amine group is amine group is basically NH2. So CH3NH2, and that's fixed that here has to be a NH2, means NPH2. So RNH2, R2NH or R3N. So N and then R could be anything, H or could be CH3, anything. But if it is nitrogen attached to it, then you can call it as an amine group. Coming to anhydride, anhydride is this functionality where you have two carbonyl groups and both of the carbon is joined with one oxygen in between. And obviously this valency is free and this valency is free. So this can get attached to either R or H. So basically R is attached normally. So it's kind of anhydride where here CH3 is attached and C double bond O, C double bond O is anhydride group. Now let us go to the right section of this table. Here you can see aromatic compound. So aromatic compound is normally which follows Huckel's rule, which is 4n plus 2 pi electron rule. And then this looks like this, alternate single and double bond. This is an aromatic compound. Now coming to carboxylic, obviously it's cyclic. Carboxylic acid that we have seen, C double bond OCOH group, carboxy group is there. Now if you remove this H by a R, if you substitute this H by a R, that means it's not compulsory that it has to be H. It has to start with a C. Correct? So that becomes ester. COOR. Now there it is surety it is not H. If it is H, you will call it as carboxylic acid. But if it is R, then you will call it as an ester. So that is the difference between carboxylic acid and ester. This has to be a R, means a carbon. Okay. Then ether. Ether means OR. When you have hydroxyl group here, OH, then if it is H, you call it hydroxy group. But when it is R, you call it as alkoxy group because alkane is there, R is there, right? Carbon is there. So for carbon, you normally use alk word, right? So that word you have to use here, alkoxy group. So alkoxy group is ROR. Here also it's R, here also it's R. So basically O is connected to a R and that becomes alkoxy group. Now here if you write H only, that will become hydroxyl group. Fine. So just make sure that both of the things are to be R, not H. Otherwise it would be hydroxyl group. Coming to ketone, as we have discussed earlier also, this is aldehyde CHO group, while if this is R, it is ketone. Now you can see it's very easy to correlate, you know. I told you carboxylic acid, then you change it with Cl, it becomes acid chloride. Then you have alcohol and then you have ether. The only difference is H and R. Then you have aldehyde and you have a ketone. The difference is H and R and it goes like this. Now let us go to the next section, nitrile. Nitrile is cyanide group also. That means if a cyano group is there, cyanide group is CN. CN is connected to a R, it becomes nitrile. HCN is also there. HCN like hydrogen cyanide, that is also there. So R could be anything here. Coming to sulfide, so alkyl thio group, that means alkyl means obviously R has to be alkyl, then thio means sulfur. So whenever you have N, you call it as nitro, but whenever you have S, you call it as thio. Now there is one more thing, thiool, right? So this one is thiol, means obviously all is added here and all means hydroxyl group. So if this is H, SH, if you can see here H, then you will call it as thiol. But if it is R, you will call it as alkyl thio. Correct? So SH could be mercapto also, thiol also, if only H is there. But if two alkyl groups are there, you will make it as alkyl thio group. Then you have thioester. Now the name itself suggests you have an ester and then you have thio also. And that means thio means sulfur. So there has to be a sulfur. C double bond O, SR. This unit is for thio and this unit is for ester. Ester was ROR, I guess you remember. Ester was here only, here COR. But if substitute this O with S, then that becomes thioester. So I guess with this you are able to understand what are the functional groups available in organic chemistry, and if you are able to like, please hit on like, that will give me motivation, and please do subscribe the channel for more such updates. Thank you so much.